My name is Ramses Ramirez, and I'm a professor of physics in the planetary science group, and I'm also the director of the Laboratory of Planetary Habitability. And what we do here, we model and simulate the atmospheres of potentially habitable planets in our solar system and beyond. So we look at trying to figure out and unravel the conditions that make planets more like the Earth and try to understand why Earth is so different. Why do we have life? Why are we a blue pearl with clouds and oceans and seas? And why is Mars not the same way? Or Venus? So what happened to those worlds? Why do they undergo different trajectories? And in turn, from understanding how our planet became habitable as opposed to the others, can we find other planets that are potentially like Earth and habitable? A lot of students are really interested in our work. They're really interested in helping out, trying to understand planetary habitability and trying to find life outside of our own Earth. We're trying to find that second Earth, right? So, and a lot of people are really interested in these topics because it really gets to the center of a central question we have as mankind. Are we alone in the universe? And so that's a central driving question that drives my research. Our research in our lab is trying to understand that question, whether we're alone or not. And no matter what the answer is, it's exciting. So we have students from all levels of education, at least college education, from undergrad all the way up through beyond into the postdoc phase. Our role in our lab is to help the observers interpret what they're seeing, right? So they find planets and we can tell them, hey, those planets are potentially habitable. They may have life because our models predict, hey, this planet is in the right spot within the habitable zone to support life or not. So my role is to help guide the observers. Our role as a group is to guide the observers on these missions, which, by the way, are using our habitable zone limits that we've calculated. For instance, the Kepler mission that's out there, JWST, and upcoming missions like the Habitable Worlds Observatory and whatnot, they're all using our definitions of the habitable zone that we've calculated to infer which planets are potentially habitable or not. So those concepts are something that we're driving. They're using our work. What excites me the most about my research in our lab is basically, again, this the big central question in our work is trying to understand, is there another Earth out there? Are we alone in the universe? The one thing I'd like to add is we are certainly always looking for students. We are always looking for collaborators. So if any of this sounds interesting to you, whether it is trying to understand the habitability of Mars and how it had its once thick, warm atmosphere, what happened to it over time, or other topics, how planets form, how planets get their water from the very beginning, how planets become habitable from the very start of their formation, any of these topics and more, we are more than happy to bring you into our fold.